Hello, today I'm going to show you how to assemble the mini drone.
Please be aware that MOSFETs are vulnerable. To avoid damaging them, before soldering, I would turn its power on and wait until the soldering iron to reach certain temperature. Then turn it off and use the residual temperature to solder the components. This is part 1. In this part, all components will be soldered before shipment. You don't need to solder them by yourselves. I'm demonstrating this in case you want to hack it in future. While soldering, I will attach the components picture in schematic so you would get more familiar with the hardware. Let's start with the power switch. It's written as off/on on the PCB. Then let's solder the J1 header. It's used to download the firmware. I prefer to solder it from bottom up. We can move on to the BAT port. It's used to connect 3.7 volt battery. This header needs to be soldered really well, because large current is going through it. Now we can solder the SER port. You can use a CP2102 or other USB to serial converter to connect the mini drone to your computer. Then the firmware can be downloaded, or you can do some serial debugging with it. The last part is the Ppm port. It's used to connect with the Ppm Receiver. The receiver will convert the commands from radio transmitter to Ppm waveform, which will be understood by flight controller program. We are almost done. I did some refinements so that soldering points should look better. The RX2A receiver also needs to be soldered with wires. Let's first figure out what color on the 3-pin wire corresponds to GND. I am using the black color for GND. The white color is in the middle, so I have to use that for 5V and red for ppm pin. With that in mind, we can solder the other end to the RX2A board. On RX2A board, the I-bus pin is not used. Now we are done with part 1 soldering. Keep in mind, you don't have to do that normally, so don't be terrified. There will be 4 rubber rings to fix motors to the PCB board. With them, you can avoid using adhesive. They are also pre-installed. Personally, I prefer to put black rings in the front and white rings in the rear, so that I will know the heading of the drone. But you will always know that by remembering broken.net is in the rear. Now it's time to install motors. You need 4 8520 motors. 2 of them are clockwise. The other 2 are counterclockwise. Please cut their wires in the middle and strip the wires to expose the metal inside. Then tin it. Before soldering motors to the board, we need to put them in the right position. According to the firmware, the right front motor is counterclockwise, so we use the motor with black-white wires. Left front motor is clockwise. For that, we choose the motor with blue-red wires. Motors in diagonal direction are the same, so the motor in right rear is blue-red type. And the motor in left rear is black-white type. Let's arrange the wires to the correct position. There is a plus sign near every MOSFET. For black-white motor, white is positive. For blue-red motor, red is positive. I prefer to bend the wire a little bit through the hole. This way, wires will get some friction with the board and make soldering a little easier. After motors are soldered, we can install propellers. Similar as motors, propellers have two types. Please use clockwise propeller with clockwise motor and counterclockwise propeller with counterclockwise motor. It's time to test our drone. Let's connect it to the computer through USB to serial converter. I'm using CP2102. You might use others like FTDI. The power pin is 3.3 volt instead of 5 volt. TXD pin is connected to R on our drone, and RXD is connected to T on our drone. Please put a jumper cap on J1 before plugging the USB port. This way, STM32 will enter firmware download mode. Now we open up Mini Test Firmware and hit download button. If you can't download it, I suggest watching Job's tutorial first. He talked about how to set up Arduino with STM32 add-on. The orange text will let you know when it's done. Then open up the serial monitor. Wait the text to show up and input Command F. It will switch on blue and green LED accordingly. If we input Command B, it will scan I2C bus. Command C is to test the gyro. Command D is for the accelerometer. Command E is to test IMU. It combines data from gyro and accelerometer. To test the rest items, we need the battery. There is a plus sign near BAT. It's for red wire. You will see the RX2A receiver powered on by the battery. Now we connect it with the USB to serial converter and input Command G. This is for measuring battery voltage. If we switch on and off, the measurement result will change. Let's open our radio transmitter and turn it to binding mode. We also need to hold the receiver button and turn its power on. This way the receiver will also enter binding mode. It will flash under a different frequency in each status. Since transmitter is powered on and in binding mode, it will immediately pair with it. Now you can reset the transmitter to normal mode, and the receiver LED will be steady on. We can input Command A to check receiver signal. If something isn't right, you can change settings in transmitter. The last step is to test motors. You can input 1, 2, 3, 4 to test motors individually. Make sure the propellers won't hit anything. You can also input Command 5 to test all motors. All tests are finished. We can now put back the jumper cap and flash the flight controller firmware. Once it's done, please remove jumper cap and reset. You can fix the receiver board with double-sided tape. The battery can be fixed with rubber bands. Now switch on the transmitter and the drone. Wait a few seconds while gyro is calibrating. Unlock the drone and happy flying. Next video I will change the valve to control brushless motors. It's more exciting to fly with F450 drone, isn't it? Thanks for watching.